In this video, we developed the derivative formula for sine, and to do this, we're going to need a little bit of background information. First, we're going to need the derivative, expansion formula for the sine of alpha plus beta, and that, of course, is the sine of alpha cosine of beta plus cosine of alpha sine of beta. In addition, we'll need some limits that were developed in section 1.6, and those are, first of all, the limit as h approaches 0 of sine of h over h is equal to 1, provided h is measured in radians. This limit, I think we stated in terms of x before rather than h, but we'll use it in terms of h today. All right, and the limit as h approaches 0 of cosine of h minus 1 over h is equal to 0, provided h is measured in radians. Actually, I think this would work if h were measured in degrees, but we did use the fact that h was measured in radians because we had to depend on that other limit. So keeping these two limits in mind and the one expansion formula, let's start with to take the derivative of sine of x. By the definition, this is going to be the limit as h approaches 0 of sine of x, but remember each instance of x will be replaced with x plus h, so that would be sine of x plus h minus sine of x all over h. Using the expansion formula, where x is playing the part of alpha and h is playing the part of beta, we have this is equal to the limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus cosine of x, all divided by h. And remember, the first two terms here come from this expansion formula, so they together make up the sine of x plus h. And then we had to subtract, oops, I think I put a cosine here rather than a sine. We had to subtract sine of x. All right, let's work on this. Okay, we have two terms involving sine of x. Let's combine those, all right, and then we can take out a factor of sine of x. And if we do that, we'll have the limit as h approaches 0 of sine of x that I've taken out times what will be left in this first term is cosine of h minus 1 from this last term. This will all be over h, and this would be over 1. Okay, so sine of x over 1 times cosine of h minus 1 over h plus, in this term, I'll take out the cosine of x, and I'd have cosine of x over 1 times sine of h over h. Now I can go through and take the limit of the first term and the limit of the second term. The limit of the sum is the sum of the limits. Then in the first term I can take the limit of the first factor and multiply it by the limit of the second factor and do the same thing in the second term, and this would become then the limit as h approaches 0 of sine of x, or sine of x over 1, times the limit as h approaches 0 of cosine of h minus 1 all over h plus the limit as h approaches 0 of cosine of x times the limit as h approaches 0 of sine of h over h. Okay. Now this first limit, well, h is approaching 0, but sine of x does not depend at all on h, so sine of x doesn't change as h approaches 0. So this limit is simply sine of x. The second limit, the limit as h approaches 0 of cosine of h minus 1 over h, well, this limit is one of the limits that we wanted to recall, and remember that limit turned out to be 0. All right, plus, well, just like in the very first limit, this is the limit of cosine of x as h goes to 0. Cosine of x does not in any way depend on h, so this limit is simply cosine of x. And finally, this last limit, the limit as h approaches 0 of sine of h over h, this limit is 1, again, provided we're working in radians. So we have basically sine of x times 0 plus cosine of x times 1, which is simply cosine of x. So the derivative then, the derivative with respect to x of sine of x is cosine of x. And notice we use the fact that we're measuring angles in radians here. So we have to remember that this formula works provided x is being measured in radians. And there we have the formula for the derivative of sine.